this is Zora. Today I'm going to show you how to solve quadratic equation by taking the square root. I will show you 4 different examples, each at different levels. Let's get started. The first example I'm going to show you is a quadratic equation in square form. Because this is in square form, we could take the square root of both sides. We get x plus 7 is equal to positive or negative 7. You want to make sure you have the positive or negative side in front of 7 because 7 squared and negative 7 squared is equal to 49. Now we're going to subtract 7 on both sides so we can isolate x to find our solutions. Now we can combine like terms. We get x is equal to 0 or x is equal to negative 14. The second example I have for you is converting standard form that is a perfect square to square form. Like factoring, we're going to find numbers that add to b and multiply to c. In this case, we know 6 times 6 is equal to 36 and 6 plus 6 is equal to 12. So we can write x plus 6 squared because it's the same factor is equal to 9. Now since it is in square form, we could take the square root of both sides. We get x plus 6 is equal to positive or negative 3. Now we're going to subtract 6 on both sides. We get x is equal to negative 6 plus or negative 3. Now you can combine like terms. We get x is equal to negative 3 or x is equal to negative 9. My third example is converting standard form that is not a perfect square to square form. We're going to use completing the square technique. The first step of completing the square technique is to get ax squared plus bx on the left side. So we're going to add 7 to both sides. We get x squared plus 6x is equal to 7. The second step of completing the square technique tells us to add b divided by 2 squared on both sides to get a perfect square of x plus b divided by 2 squared. So we're going to multiply 6 by a half, and you're going to square that to get your answer, which is 9. So we're going to add 9 to both sides. Now we're left with x squared plus 6x plus 9 is equal to 16. Now we can factor. We know 3 times 3 is equal to 6. It's equal to 9. And 3 plus 3 is equal to 6. So we're going to write x plus 3 squared is equal to 16. Now we're going to take the square root of both sides. We get x plus 3 is equal to positive or negative 4. Now we're going to subtract 3 to both sides. We get x is equal to negative 3 plus or negative 4. Now we can combine like terms. We get x is equal to 1 or x is equal to negative 7. In our last example, I'm going to introduce you to imaginary numbers. We're also going to apply the skills from the third example by using completing the square technique to solve this equation. So first we're going to subtract 25 on both sides. We get x squared minus 8x is equal to negative 25. Now we're going to add negative 8 divided by 2 squared on both sides. So we're going to multiply negative 8 by half and square that to get 16. So now we're going to add 16 on both sides. You get x squared minus 8x plus 16 is equal to negative 9. Now we can factor. We know negative 4 times negative 4 is equal to 16, and negative 4 minus 4 is equal to negative 8. So we're going to write x minus 4 squared is equal to negative 9. Now we're going to take the square root of both sides. Now in this case, the square root of negative 9 is equal to no real solution. However, there is an imaginary solution. Imaginary solutions are represented by I. I is equal to the square root of negative 1, and I squared is equal to negative 1. Square root of negative 9 is equal to 3i. The square root of negative 9 is equal to 3i because the square root of negative 9 is equal to the square root of 9 times negative 1, which is equal to the square root of 9 times the square root of negative 1, which is equal to 3 times the square root of negative 1. And since we know square root of negative 1 is equal to I, we're going to get 3 left with x minus 4 is equal to 3i. So we're going to add 4 to both sides. You get x is equal to 4 plus 3i. Because these are not like terms, we cannot combine. So our solution is 4 plus 3i.